Hi, hello everyone. Last time we left off with our triangle, and this time we're going to try to get that data from the triangle. As you remember, last time it was actually done completely in shader, so we're now going to do it on the CPU side of the things and then going to pass it to a shader, actually to graphics pipeline or the GPU. So for that, let's wait with that a bit. So I'm just going to make some smaller changes here. So this red background, I'm actually going to use something more grayish. So I'm going to pay 0.8, 0.8, 0.8 for blue. And you're going to see this kind of grayish background. Then the second part, I'm going to refactor this a bit. So because this render pipelines, right, it's called unlit. So we're going to pull them out and then have unlit, and then further down the road we're going to have lit render pipeline. Lit means it's going to have shading or maybe Lambert render pipeline. Now I'll see what's going to be called, but let's just here say render pipelines, and then we're going to create unlit render pipeline. So we're going to need all of this. And here we can say export class unlit render pipeline. And then constructor, we're going to need a device. And then we can copy paste it here. We're also going to need this shader module part. So let's cut that as well. Move it here. And then we had this shader source. We can paste it just here. Let's format it a bit. So here the shader is going to need path change, right? Because now it's in the folder, so it needs 2 dots here. Then here we're going to say private render pipeline, GPU render pipeline. Then it's not const here, it's rather this, because we are assigning the global variable here. And then we're also going to need draw. And this draw, we're going to pull it, put it into a pipeline. So here it's this, right? Because we're using this one. And here we're actually going to pass render pass encoder, and it's of type GPU render pass encoder. In our main, we're just now going to create it. Const unlit pipeline. New unlit render pipeline. We paste device, and then we can just draw it here. And we're going to say draw here. It's just that we know where we're drawing. We draw it. Something isn't saved, so I'm just going to go file save all. Okay, it works now. That's done. So now we're going to go to the geometry side of things. And for that, we're just quickly going to create actually our data. So we're going to go new folder here. We're going to call this, well, basically it can be geometry. And this is just going to be some kind of placeholder class. Don't think too much about it. There's nothing special about this class. It's just going to contain data. And here we're going to say public vertices, position vertices. I think positions is fine. Since when you work with this low-level programming, you're going to need to use these typed arrays, which are provided by JavaScript and TypeScript. So just be mindful that you cannot pass just any array. You have to use this special kind of array, and the reason for that is this signature, right? Because you have to be very precise about the data that you're passing in. So we're just going to use stuff like this from now on. And this should be it. I'm missing a body here, so that's why it's complaining. Okay, and then we're going to have a new class, which is called geometry builder. And we can export that class. Geometry builder. We're going to have public. Create quad geometry. And we're going to return geometry. And so now here, what we're going to do is we're going to get all of this. We're going to set here vertices or positions. You can use either one. Vertices is fine, and so we're now going to create that array. Close it here, and then paste this in. So we don't need this vec14, and we don't need this last argument that only matters in shader. Otherwise, we're never going to have to use it. So you can leave it like that, and we can just return our geometry. All right, we just need to import it, and that's it. All right. So next thing is we're going to need to create. We're going to need to create these buffers that I mentioned with this data that we have here. So I'm just going to call it here attribute buffers. My bad. And here I'm going to call, because these buffers don't have to represent geometry. If we have some others, I'm going to call them proper name, but I'm just going to say geometry buffers here. Geometry buffers. And then constructor, we're going to take device. And then we're also going to take this geometry. And here it already gives some suggestions, but let's skip that for now. What I'm going to do now is just create the data that we're going to need, and the information that we're going to need is first of all our buffer. So we're going to call it positions buffer, type GPU buffer, and then also one small piece of data that we're going to need is vertex count, and that's just the count of basically this vertexes here, right? So we have 3, but we're going to actually calculate it from this data that we pass in, so that it's just of type number. And here, so how do we create these buffers? So we're going to say this positions buffer. We use device, create buffer, right? So we can pass it a label, and label is not important, it's just for debugging purposes. Here, size, we need to specify size, and size needs to be in bytes. So the good thing about this typed arrays that we had position, float 32 array, is it already has byte length. Otherwise you have to calculate, and it's usually something like you could do number of elements. We had 9, and then float 32 array, bytes. I'm not sure why it's doing this, but you would get it like this, right? Byte length. You could just use count, so positions. This is really not helping me at all. Entries, something like length time for 32 bytes per element to get bytes, right? So this is byte length, but since it already has it, we're just going to paste this in. And then usage, so we're using it in vertex buffer, so you have to paste this. And then the second argument is also kind of important. With copy destination, you're essentially saying, okay, now we can use it for copying the data to the GPU. I'm going to explain it in a second, because all of these copy operations, and here I would probably advise you to look at documentation of WebGPU, which you can find WebGPU draft. I think here you can find it, and then you have to search for copy destination. This is from texture, buffer usage. So it says here that it can be used as a target of write buffer call. All right, that's kind of important thing, because we're now going to use write buffer call. So let's go here. So this is just define the size and the usage. Now we have to actually write the data to the buffer, and I'm going to use device Q, right? And then write buffer. So what's the buffer? This position buffer. The second argument, buffer offset, we don't have any offset, but if you for any reason have offset in data, you can use it. Then we're going to say here geometry positions, buffer source, right? So it's our buffer source, which is from the positions, right? So this is the reference to this created buffer. 0 is we don't have any offset. Then we have third argument, which is actually our data, right? We're just passing this buffer from array like. This byte offset, it's actually 0 here. We don't have any offset in our data that we're passing in. And here it should be just byte length. Exactly. So size of content, yeah, exactly. It's same as here, right? The size of the data that we're passing in. Okay, that covers that, and we just have to assign our vertex count. This vertex count is, so why 3 here? Because we have x, y, and z positions, right? So our vertex, we need to offset for those 3, so we'll just divide by 3. And I think we're good here, mostly. If I save, somewhere something is unsaved. I'm just going to do this. Aha, we have in our shader. So in our shader, we had this built-in position, but we're also going to have another struct, and I'm going to call that struct vertex shader input. So we're going to have layout 0, sorry, location 0. I'm missing some stuff up because I'm used to WebGL as well, and there it's called layout location. So here we have 0 position, vector 3f, right? Because we're passing 3 elements, x, y, and z position, so that's why vector 3f. And here we don't have this anymore, and our position is now going to be vector 4f. And here we just need to specify, so let's just say built-ins, and here we're going to say in vertex shader input. That's fine. We're going to use in position, and then you just want to set the last element to 1.0 of vector 4, right? Because here it needs to be vector 4 always, this position, right? The output position needs to be vector 4, but the input can be vector 3. And this last element is actually used for projection quite often, and it's also called homogeneous coordinate. It's also used for transformations. We're going to cover that in futures. For now, just leave it as 1.0. Pass it out, and I think we're good here. All right. Before we can use that, we actually, in our render pipeline, we're going to need to pass something called buffers here, and that's of type GPU vertex buffer layout. So I'm just going to create this buffer layout, and this actually needs to be array. For now, we're just going to have one, but I'm going to do it like with the push commands. It's just going to be easier to read in the future, I think. So we need to describe this layout, right? We need to describe how this data is going to look like when we paste it to our shader, right? So we can see here already some information. This location is going to be important, and this vector 3 is going to be important, right? So here we're going to have array stride, and the array stride needs to be in bytes. So we had 3 elements, right? The stride is size of 1 vertex, right? If you remember, we had this basically triangle that was going somewhere here, and we need to describe the size of this one vertex. So what's the vertex size? Well, it had x, y, and z, so we already have 3 from here, but it needs to be in bytes, and it was of type float, if you remember. So we're going to say 3 here times float 32 array bytes per element, and that's going to be our array stride. So we need to describe it here, and we say attributes. So we can do something that's called interleaved buffer, where we can pass one buffer and it pass multiple types of data in it. We're not going to use that for now, so we're just going to say attributes. So this is important, this shader location, right, is corresponding to location in our shader, this location 0. Offset, we don't have any offset, so this offset is if you want to skip some bytes, we don't need it. And then format is float32 times 3, so this 3 comes from x, y, and z, and float32 is because this is in bits, and I hate this because sometimes data is in bytes, sometimes in bits, right? We know that we have 4 bytes for float. You can see it here as well. In bytes it's actually 4 bytes is 32 bits. Anyway, so let's go further. So we just now need to push it here, buffer layout. And then here in draw, we're actually going to take these buffers as a parameter. So we're just going to say geometry buffers. And then here in the pass encoder, we need to set that vertex buffer, slot 0, right? This also corresponds to this slot location and also in shader. So we're going to paste that in. And we're going to say buffers position buffer. That's it. And here I'm just going to use buffers vertex count. If I save it, it should generally work, but we still haven't created that geometry. So here I'm just going to say geometry is new geometry builder, create quad geometry, and then const geometry buffers. We can create that as well now. And this needs to be const. And then we can just paste them in here. And it works. Alright, cool. So further, we can make a quad of this. And how do we make a quad? Well, we can just add second triangle, so it's going to be really easy. And here I'm actually going to describe them with top with position, actually, not 0, 1, 2. So this one is bottom left, this one is top left, and this one is bottom right. So that's our first triangle. So I'm just going to say T1 here, and then T2. So we can go, actually I want to go from top left. So I'm just going to describe 0.5 top left. Then I want to go to top right. Alright, that's a good suggestion. And then to bottom right. Alright, and as I said, you can already see it works. Why it works? Well, we just added it, and then in our geometry buffer we actually calculated this vertex in account. So that's why it automatically works. Cool. So that was easy to cover, right? We just had to specify 2 triangles basically, and then it works. So we had this one, and then we specified it like this, the second one. Okay. So now I want to cover something in this drawing. As you can see, this one top left is duplicated here and here, and this one bottom right is also duplicated, and we can avoid that with index buffers. And index buffers are just nothing but the lookups into essentially the vertex buffer. So let's do that. So for our geometry, we're going to need something called public indices, and I'm going to use unsigned integer 16 array. You can also use 32, and the difference is just in maximum size, right? For 16 it's going to be 65,000 and something, right? And for 32 it's going to be way higher, but also difference is also in size, right? This is 2 bytes, and then if you have 32 then it's 4 bytes, right? So it takes more memory, but you can write more into it, more data into it. So I'm just going to use this one. It's not that important because we're not going to have like huge model of couple of hundred thousands vertices or whatever. Anyway, all right, here. So now we can just say here like indices, new event 16 array, and here this first one we can just go 0, 1, 2. That's fine. And for second one we have actually to think about it. So this top left is duplicated and we don't need it. And here we can see top left is at position 1, right? Because we're going from 0 when programming. So top right is not duplicated, so we're just going to remove this. And we can just leave top right here index, so that's 3. And then we had bottom right, and bottom right is 2 here, so we're just going to paste 2 here. And that's our T2. We can say indices. And then in our geometry buffer, so this is broken right now because right, we don't have enough triangles, but here we're just going to say public with only indices buffer, says buffer, and I'm just going to make it nullable because we might have it and might not, and same for index count. So we're also going to have index count, and here let's just say positions, and then indices. So if we have our indices, right, if geometry dot indices, and then we can say also dot length is greater than 0. And here I'm going to make this null, and I'm just going to say it's always going to be defined. You don't have to, it's complaining though. Because obviously. So even if we don't pass it, I'm just going to create a default one. So now back to geometry buffer. So we need to define these indices. So we can pass it a label. So we created the same as index buffer. Just be mindful here. It needs to be of GPU buffer index, and the rest of it can remain mostly the same. So how do we write it? Well, the similar, right? We pass this index buffer, indices buffer, then the data, and then the byte length. And for the offsets, we don't need any offsets. And then the count, this is the difference. The count is just set from the length. So there is no need to divide anything, right? Because index is 1 per vertex. All right, so that covers that part. So now we just need to draw with it. And if I go to our unlit render pipeline, so here I'm going to make this, and I'm going to say if buffers dot indices buffer. So if we have it, right, I'm going to do something, and if we don't have it, we can draw normally. So let's just format this, and I'm going just to say small descriptions here, draw with indexed buffer. So what do we need to do? Well, we need to pass that index buffer. So we can just set our index buffer and type. This is important. If you use 32, you're going to say 32 here, but we're using 16, right? 16 bits or 2 bytes. And then we can just say, instead of draw, we're drawing indexed, right? And then we just paste index count here. So I had to unwrap it because it's it's nullable, and this guys remains the same. So it's just one instance, first index, and then we just go from 0 from everywhere here. And if I save it, changes are applied, and we have our quad once again. Okay, one last thing, I just want to color that quad, and for that we're going to also pass another type of data, which is colors. So here I'm just going to say location 1, so we need to use another location. Then I'm going to say color, and here I'm just going to pass vector 4, and we also need to output it to fragment shader. So I'm going to say location, and here it's going to go 1. So this is built in. That's a bit different because this really needs to be used by one of the stages in the pipeline, right? And here we're just saying, okay, this goes straight to fragment shader. Okay, then we need to set this out color and then color. And here, so what's going to be in? Well, it's going to be vertex shader output. So we're just going to paste that in. We can say in dot color. So I think we're good with the shader here, but it's always broken because there are some steps that we need to do first. So first step is we need, similar to this thing, right, where we described positions, we need to describe also these colors. So array stride, this is wrong suggestion, it's 4. It's 4 because we have red, green, blue, alpha. Then shader location 1, offset we don't have any offset, and here it's 432 times 4. And I think regarding our description, that's quite alright. So then we just need to paste here to our geometry. So it's going to have colors, floated to array, geometry builder. Let's define those colors. So I'm going to go red, then green, blue, and then yellow. So colors here, they're not that important. You can use different colors as well. It's just an example, and we also need to paste it here. So we have our colors defined, and now we just need to create that buffer. So here I'm just going to say public read-only colors, and I'm always going to create it regardless. And here we can say our colors. All right. So once again we create buffer, which stage vertex, this scope destination, so that we can write to it. And yeah, this all of this else is the same, and so we just write to it, right? Once again, write buffer, we paste our colors buffer, our data, and then the length of it. And one final step in our threaded pipeline, we just have to paste it here, like positions. And so the position location was 1. By pasting color buffer, it actually works. So I got everything to work without even debugging, so that's perfect. All right, so okay, here something is wrong. I can already see this color is purple. It actually shouldn't be. I was thinking, well, it can be. It's not that important. So here, I want yellow. I mentioned yellow, so I'm just going to reverse this. Yeah, that's fine. Okay, so that's basically it for this video. Just to quickly recap, well, the whole point of this was really to pass our data from the CPU to the GPU, and for that we need to define in shader, right? That we're taking in some data. So you kind of need to be very specific about the memory layout of things and how they come into. And so we had our first position, then we had also color, and you need to specify this, right, for the so that it knows type of data in the layout. But you also need to specify layout when you're creating a pipeline, which we did here, right? And then we paste it to our pipeline somewhere over here. That's important. We paste in the layouts, and then we just need to create these buffers, right? So we need to, well, buffers is just an object that's going to represent that memory, and then we just paste it to the GPU as well here. Well, anyway, you get the idea. So for the next time, what we're going to do is, I think I may do texturing. I kind of wanted to do global buffers, right? Because we have this idea of attribute buffers or per vertex, right? All of this data was per vertex, but we don't have to paste it per vertex, right? It can be also global in shader. So we might do that, or texturing. I'm not sure, because we will have to cover both. Anyway, we'll see. So if you enjoyed the video, please like, subscribe, maybe comment. If you have any questions, you can also join Discord channels, and until next time.